The discussion of stormwater collection and treatment systems begins with an understanding of road designs. To prevent ponding, a properly constructed road is crowned at the center to direct rainwater to the sides of the road where it can flow off the road or into catch basins. The edges of the road may also receive stormwater flows from driveways and other impervious areas. A catch basin is one of many input points into a storm drain system. Other input points include directly connected roof drains, curb inlets, and trench grates. The majority of inlet points are the standard roadside or parking lot catch basins. What we see above ground is a steel grate, which allows water to enter and keeps most large debris out of the below ground structure. The typical catch basin is constructed of concrete or brick and contains water and debris like leaf litter and sand at the bottom. That area that collects the debris is called the sump and may have standing water at times. When the sump fills with water, there's an outlet pipe to drain the structure. The illustration shown has an outlet pipe with a downward-facing elbow to reduce floating debris and oils from exiting the basin. Many of the newer or refurbished catch basins have this hooded structure, but older structures typically have a simple exit pipe. This exit pipe usually connects to another catch basin or a manhole structure. Manhole structures are used by most utilities and are most common in sanitary sewer collection systems. Usually, one can determine which utility a manhole is associated with by a label on the cover. The word sewer, or the letter S, is used for sanitary sewers, and the words drain or storm is used for the stormwater structures. There are many unlabeled covers, and they tend to be associated with stormwater, but not always. It is not uncommon that an incorrect cover is used on a structure. A stormwater manhole is a junction structure for the storm drain system. Most are located within the road layout or easement. These junctions allow access to the network for servicing and cleaning and are used where pipes conjugate or require a change in direction. Like the catch basin, the below-ground portion of the structure is a sealed cement or brick basin with a sump. Pipes enter or exit the structure above the sump. A sanitary sewer manhole is a similar structure. When examining structures, the significant difference, in addition to the pungent odor for sewer junctions, is the construction of the structure. Instead of a sump, a sewer junction has a channel that transports both the wastewater and the associated solids. Connecting the storm drain structures of catch basins and manholes are a network of pipes. Being underground, this part of the system is difficult to inventory and service. Using observations of visible catch basin pipes, manhole pipes, and as-built engineering drawings, some of the network can be determined. Where no drawings are available or an illicit connection is suspected, pipe mapping requires the use of investigation techniques such as dye testing, smoke testing, and pipe camera observations. Stormwater pipes are constructed of many different materials and sizes. Typical sizes range from 4 to 36 inches. However, larger pipes may be observed. Materials used in stormwater pipes include clay, corrugated galvanized metal, PVC, transite, which is an asbestos cement, concrete, cast iron, ductile iron, plastic, or steel. Storm drain networks are laid out into two basic configurations. An online configured storm drain system directs stormwater to flow through catch basin structures without manholes. During storms, high flows within the storm drain system may clear debris and contaminants from the catch basin sumps. Dislodging the sump debris makes these structures less effective in retaining pollutants. This configuration is most common on older or more rural roads. An offline storm drain system redirects stormwater flows through manhole structures, reducing high-velocity flows going through catch basins. This type of network is more effective at retaining sump debris and thereby reducing pollution at the discharge point. The offline design is superior to the online design. Storm drain networks typically discharge to uplands, stormwater management structures, surface waters, wetlands, streams, or coastal waters. Discharge pipes vary in design and size and can be difficult to locate in the field. Some are obscured by thick vegetation or buried by debris or soil. In coastal areas, discharges are often impacted by tidal changes. Many cannot be found even during low tide. Another type of discharge point is the roadcut. This is a distinct location where stormwater flows over land on the road surface to a single point. Often, stormwater from roadcuts create channelized flow to downstream wetlands, streams, or coastal waters. Regardless of whether the discharge is an outfall pipe or a roadcut, the water quality at the discharge point is a reflection of its stormwater catchment. The area that contributes flow to a discharge point is called the stormwater catchment. The catchment may include impervious surfaces such as pavement and rooftops, along with landscaped areas, parks, and undeveloped land. The catchment is defined by topography. This is an example of a catchment area of an industrial site. It includes features like roof drains, a swirl separator, and a detention basin. In this case, there is a large area of impervious surfaces in the form of parking lots and flat roofs. The detention basin collects stormwater from 3 discharge pipes. Over the years, several types of structures have been developed to address pollutants associated with stormwater runoff and the impacts to downstream resources. A couple of examples of the more typical treatment structures used in the Buzzards Bay watershed are illustrated in the following slides. Subsurface infiltration structures are underground holding areas that receive and store runoff from impervious areas. These structures allow stormwater to slowly infiltrate into the surrounding subsoil. They promote stormwater infiltration to help recharge groundwater, provide pollutant removal, and reduce discharge to receiving waters and drainage systems. A swirl separator is a generic term for many proprietary systems like Storm Scepter or Downstream Defender. The devices work by slowing down flows to allow sediments to be dropped into a collection structure, which is assessed by a manhole. Some use a baffle to slow the flow, and others use weirs. These prefabricated structures are typically used in 2 different ways. The first as a pre-treatment device to remove sediment prior to discharging into a downstream stormwater treatment system. The second, in a retrofit situation where treatment options are limited. In coastal waters such as Buzzards Bay, research has indicated that these types of structures are not very effective in removing pollutants such as bacteria and nitrogen. Stormwater treatment systems that are sized to treat a certain volume of rain may not have enough capacity to treat the entire stormwater catchment during all storm events. Most have an overflow pipe to drain the system when it's overwhelmed. That drain pipe becomes the discharge point for that storm drain system and catchment. The representation of structures described in this video can be different than the structures observed in the field. Regardless, all stormwater structures are part of a network of stormwater collection and delivery. This brings us to the end of the video. We hope you found it helpful and check back on the Buzzards Bay Stormwater Collaborative YouTube channel for more upcoming features.